Hey, everybody, and welcome to the September edition of Power Hour. Sharing the screen back up here. It's good to have everybody today, and we've got a good one for you. NovaTech's been proud to put these on for a few years now. Today, we're going to have another networking program for you. Notice the number is 102. It's not 201. 102 is going to be just a little more of the basics that we couldn't cover in our first session. So excited to bring that to you. So who's the talking voice right now? My name's Shane. I'm the supervisor of the sales application engineers. Special guest for you today, got Tom Miller, the newest addition to our team. Tom, say hi.
Hey, good morning.
Awesome, thanks, Tom. And yeah, just really excited to bring this for you today. So let's kick this off. All right. Okay, here's the agenda for you today. First thing, no basic networking discussion can basically be had without your discussion of the network layers, the OSI model. So we will run through that again, just as a refresher, or maybe the first time if you missed the other one. We'll also talk about, I guess, pull the car over and talk about some layer one stuff, the physical media, and a little bit about that. We spend a lot of time there when it comes to designing. So I think it's valid that we understand pretty well what's going on there. We'll also talk about some network topologies. Again, I don't promise to, on this one, have all the answers for you. It's kind of a basic treatment. You are free to ask questions, so please do that. And we will try to either respond live here or we could respond later as well. Okay, and Tom, feel free to pause me with any questions as we go as well. All right, and if there's anything with the webinar, you can throw it in the chat as well. We can see that. We'll get into some layer two management concepts. That's really a basic treatment. And then finally, we have kind of as a hard break from our programming here, we have a new piece of networking equipment to share with you that is available for you to order or work on. So let's continue. All right, review time. There's a lot going on in this slide, so we'll spend a little bit of time here. You have, and I'll get my fancy laser pointer going here.
Hey, Shane, before hopping in, I just wanted to let you know that you have a hand up.
Yeah, guys with your hands up, if you could throw that question in the chat, we'll see it over here. Or if that's a mistake, never mind. All right, so we're going to continue for now until that question shows up in the chat. So first of all, you've got a couple of networks shown here. At its simplest, networking is connecting computers together to communicate. I'll leave those architectures for Tom later, but as you can see here, you have a network one, and that's a LAN one, a local area network, and you have a network two, a LAN two. So in network one, you are kind of in this zone down here, connected to a switch. You could actually draw this with more than two computers. Technically, you could connect two computers directly together that way, but in network one, you'd be connected through this switch. If you want to connect two different networks, say across the internet, say your computer for this webinar today, you would be connected through the internet through a series of basically routers. Which would allow network one to connect to network two efficiently, even though natively those networks cannot talk. So we will explain that. So let's say that I'm this computer here on the bottom right, and your computer is up here on the top left. That packet actually needs to go to, or that data needs to go through a switch. The switch realizes that, hey, nothing here is identified with the destination of this. In a MAC address sense, the router says, hey, I have it. And so then the router passes it through and then is able to go to this computer here. That's the basic idea. That's how we're having this discussion right now. Over here on the right, we've listed out the OSI model. There are 7 layers. You hear about the 7 layers a lot. Just a review from last time. In practice, there's really like 5 layers that we deal with. Layers, session, presentation, and application are kind of merged up in TCP. But in any academic study of networking, you're going to be looking at 7 layers. So that's why we have them here today for you. Just a fun review, the mnemonics of this. There's a couple way people remember it. Top down, the encapsulation direction. You might say all people seem to need data processing. That's a one mnemonic. Some people learn it bottom up or the de-encapsulation direction, and that would be please do not throw a sausage pizza away or some such thing. So anyway, there's many ways to remember that, but it helps you remember what the different layers are. So let's continue. Okay, how do the layers move? So you could have a moving fancy graphic, but you know, maybe that would help. You might be able to look one up of encapsulation and de-encapsulation. Ours is a little bit static here today, but let's try to move through it with our minds here. So again, back to the example of me sending you webinar data and you receiving it. Let's show you how that would actually work here. So that's called encapsulation and de-encapsulation. So this story starts up here with device A. I have some data for you. So that data is going to be, let's say it's just HTTP data for simplicity. There could be other protocols at play here, but just for pure simplicity, just HTTP. Okay, so that's going to happen at layers 5 through 7. The data itself, which is going to be a chunk of voice and picture, is going to be chunked up, and I'm going to send you or put them together like this. Call it, it's good to think of it like an envelope. That's a good example for how this works. And as you go down this list, I'm putting envelopes inside of envelopes. That's one way to think of this. Then down at the transport layer, we are adding a layer with TCP information. That is very basically just going to be things like ports, and then also some like control protocols of how the data is going to be transmitted back and forth. Then for more addressing, we have another envelope here. We actually have to talk about network address. Where's this going? And then down at the data link layer, another envelope, we have more of a physical address. This is like the port level, physical ports. Like if you look at an Ethernet switch, it has a bunch of ports on it. This is what we're talking about at the data link layer. Those ports are identified and findable via a MAC address, a machine address. And then finally, you have your physical medium, which we're going to be spending some time on today. Excited to share that with you. But your ones and zeros, we got to transmit this. And since we have all of this encapsulated in this frame, layer 2, you have a frame, layer 3, you have a packet. Since we have all this, our networking equipment all follows these rules. They know what to do with it. So through the internet, it'll probably bounce 3, 4, 5, 8 times before it gets to your network through your router. And then once your router gets it, it will pass it toward your computer and start opening these envelopes. That router has a port. So the switch and router are going to use MAC addresses to pass the data port to port. Then there's IP addresses. Well, I got to know what computer to give it to. So that will be done at the network layer. And then you have a protocol you're following to, to talk. So are we doing TCP where we confirm? Are we doing UDP where we do not? That can even be mixed in real time. But that's beyond kind of the scope of this. And then the actual data is then unlocked from the inside envelope. And finally, it gets to your computer. And that's happening many times, even per second, as we do this, because it chunks the data into usable sizes. You don't want to have too large of packets because that can cause problems for your equipment passing it. So there's a lot of overhead here, but it ensures a reliable and kind of an expected behavior for communications. Okie dokie. All right. So with that, I'll have Tom unmute here. I'll still run the slides for him on this one, but Tom, do we still have you with us?
You do, yeah. Thanks, Shane.
Oh
And
yeah.
digging in a little bit more on layer one, like substations, networking and physical media are large industries that are used widely while evolving. Physical media prior to hubs and switches used coax cables back in the 80s to communicate between devices. Speeds were up to 10 megabits per second, with the thin net standard rated at 200 meters and the thick net standard rated at 500 meters. As you can probably tell by the visual, the terms thin net and thick net were coined based on the cable used to manufacture the different standards. And as networking evolved, hubs and the RJ45 terminated Ethernet cable became available. This era opened up a central mechanism for making connections easy from cable to hub, but also this made connections easy from cable to end device by using a PCB board soldered together and installed within the network devices. But due to the original hub-style traffic, all data was broadcast to all the devices connected on the network. Collision and bandwidth limitations restricted these networks. But speeds did increase up to 100 megabits per second for hubs. But now today, the modern Cat8 Ethernet cable can support speeds up to 40 gigabits per second over short distances, which I believe is just measured just under 100 feet. All right. And as networks expanded, smart bridges and the modern L2 Ethernet switch was introduced to reduce collisions and increase bandwidth. Modern switches today have built on this foundation, and they've added management interfaces, increased speeds up to 1 gigabit plus, and some additional interfacing and control that we'll touch on a little bit later in this power hour. We see devices and substations today more devices being added to networks as RTUs evolve and electromechanical relays get replaced. Many have converted from copper to fiber for layer one physical media, which we'll dig into a little bit more on these next few slides. All right, networking and fiber optics. So we're essentially converting network traffic to communications based on the principle of guiding light by refraction. So this principle is actually first demonstrated in the late 1840s, but we didn't see the first functional fiber optic system application patent until 1966. So what optical fiber is, it's a highly transparent strand of glass plastic that's used to transmit impulses of light that will refract through the core and provide a signal to the receiving end. With the fiber transceiver installed within the devices on each end, it will convert these electrical signals to optical signals, most typically using a laser LED on the transmitting end and a photodetector on the receiving end. So essentially, to confirm good communications with the device, the modulated optical data that is sent must be received with enough power to be detected and demodulated accurately. And then because this transmission of data is actually through pulses of light and not electric current, fiber optic cables are not susceptible to EMI. This makes them great for installations near high voltage transmission lines, high horsepower motors, and any other large EM field generating equipment. Fiber communications also have a much lower signal attenuation over long distances when compared to copper. Although fiber networks have a higher cost initially, and the fragility of the cables can make installation and maintenance more difficult, we've seen it be widely used for applications that require fast, stable comms over long distances. Okay, so to drive down a little bit deeper, the two main modes of fiber are single mode and multi-mode. For single mode fiber, it has a much smaller core diameter. So because of this, it only allows a single light mode to propagate and allows that light to travel at a fixed duration. The smaller core in the single mode cable allows for high bandwidth over longer distances. So I believe that's up to 40 kilometers, and that's with minimal signal distortion. Whereas multi-mode, The larger core can send multiple modes of light simultaneously at varied durations. This can limit bandwidth and cause the signal to be more susceptible to attenuation factors. So we've seen multi-mode applications be more suited for shorter distances in comparison. So cost, on average, you'll see single mode is a little bit higher due to the higher cost of transceivers, and it's slightly more complex to manufacture those cables. So now that we looked at the cables, we can look at the terminations. They're terminated with a variety of different connectors for different applications, density, or performance. For example, you'll see FC connectors utilize a metallic body and spring-loaded ferrules, which make it suited for high vibration applications. However, you will see slower speeds than LC connectors. Each connector's name abbreviation is tied to how it works or how it came to be somehow. And as I say that, the first one is SC, where there actually is no defined name in their paperwork, but it's commonly referred to as the subscriber connector, square connector, standard connector, or stick and click, as it uses a push-pull connection. Your LC is going to be your Lucent connector, named after the inventing company, Lucent Technologies. It's at about half the footprint of the SC, and it uses a clip-style connection. Your V pin is pretty straightforward. It's a V groove pin. It coined the name from how it connects, as it does not use ceramic ferrules, but a V groove pin instead. Your FC is going to be your ferrule connector. The major difference here from others is that it uses a threaded screw-on connection style. Your ST is going to be your straight tip. It uses a twist and lock mechanism where the ferrule slightly recesses for connection, so it can keep a little bit of a tension on there. Lastly, the MTRJ is our mechanical transfer register jack. This connector uses an RJ style housing with two fibers. I'm sure you can see the use case here, but this connector is mostly obsolete now. So here at NovaTech, we do use the LC connector in our fiber SFP transceivers on our Orion network ports, but we also offer ST and VPN fiber serial card options on the Orion LX Plus and our Orion MX. And like serial communications, simplex communications are used for one-way transmission, whereas you need half duplex or full duplex configured on each side for two-way transmission. Here you can see some common ratings for specking fiber. Most everything you're going to see is organized by single mode versus multi-mode initially, but then it kind of drills down by wavelength, attenuation, and data rate supported. You can use this to weigh your application's distance, speed, and budgetary requirements. Some common ratings for single mode and multi-mode are OS, optical single mode, and OM, optical modulation, respectively. So you can just kind of see in the charts here to the right a little bit how they compare. I believe OS only has two different modes, which is OS1, which is a little bit older, and OS2, which is the more modern factor. OM, I think these charts are even a little bit out of date, where they're up to OM5 and potentially OM6. So now to pivot a little bit and go over a couple of topologies. I'm going to start with some non-redundant options first. First and simplest topology that isn't pictured is a point-to-point. This is a direct connection allowing two devices to communicate through maybe a fiber cable. There's no network switch needed. To expand from two devices on the network, we can look at the first picture topology, the bus. This was an older method of allowing network traffic without a network switch. If physical space and bandwidth allow, the network's easily expandable, but we do see many points of failure. We can see the presence of the network switch in the star topology, and in my opinion, this is the most natural way that network topologies get configured. Just plug everything into the switch and start talking. With ports available, expansion is easy, as the option to connect a second switch is available. The double-edged sword here is if a device fails, it will not affect the connections to any other devices, unlike the bus topology. But if that device is the network switch itself, it'll obviously cause total loss of the network without any redundancy. Now adding some redundancy. Unsurprisingly, redundant topologies offer a higher cost but provide higher reliability. With the ring having connections to each of its neighbors, network traffic has multiple options to travel around the ring to keep networks running during maintenance or construction. The mesh topology provides a connection to each device for an array of data flow, but it does increase your difficulty of troubleshooting and managing the network. Um, Redundant networks require a more complex configuration and either a physical or logical break to avoid broadcast storms. With all these redundant paths, traffic broadcasts onto the network can eat up bandwidth by constantly passing broadcast and response packets. And getting into more complex networking and adding redundancy is something that's often done at the network switch level. So these images, they do look like desktops, but they could be switches with each one hosting network traffic from an array of devices themselves. And so that is more where we see redundancy added into to our networking. All right, now casting onto the network. After we've looked at our different network topologies, we can pivot and look at how traffic is cast onto the network. Unicast, it's direct, it's routable. Examples include engineering maintenance and configuration, such as uploading a new file or changing a setting on your device. Also, 61850 MMS protocol to communicate with an IED that uses a unicast style of traffic. Broadcast is near the opposite. Broadcast packets are transmitted to all devices on the network. This can be seen in our layer 2 ARPs. That's when a packet is broadcast and the responses have been received by our layer 2 switch. Our layer 2 switch can then tie the responding IP addresses with their corresponding MAC addresses. Remembering our encapsulation slide from earlier, an L2 frame actually contains more data than an L3 packet, and it does contain the MAC and IP addresses. And so that data is then used to create MAC tables of all the devices connected to that layer 2 switch. Network update notifications are also another example of things that are commonly broadcast on the networks, but none of this data is going to be routable. So then moving on to multicast, this is seemingly the most useful as we can still, thank you, as we can
Sorry
still
about that.
cast to multiple devices. But you can actually specify how large the cast is going to be with a range of IP addresses for devices that are interested. So we can still have devices on the network, but we don't necessarily have to route all the traffic to them. And then with additional management and configuration, multicasting can also be routable to remote networks. Okay, we've touched on packets, we've touched on frames, we parked on layer 1. Now we're looking at layer 4 and comparing how these packets travel through the transport layer. Two main protocols are TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. A driver behind using TCP is that it's connection-based. It'll establish a handshake. I don't like the term handshake because to me that's only one point coming from each side. As you can see in the visual, device B is sending 2 points. So I prefer the term opening the door, or if device B were to open the door and device A were to say thank you, at that point they have both acknowledged each other. But for TCP, device B now says you're welcome for that TCP communication to begin and start passing data. So TCP is also outfitted with error detection monitoring bad packets. Compared to UDP, it doesn't use any sort of handshake, no flow control, no error detection. So for this, it's commonly used for high-speed non-critical applications like video streaming. In this application, device B can receive a large amount of high-quality graphics and datagrams at a high rate of speed, and so this helps avoid buffering and streaming in 4K or other high quality. And so that was just a quick touch on layer 4 protocols. And now I'm going to pass it back over to Shane to lead you through some layer 2 management concepts.
Thanks, Tom. Appreciate that. We do have one question here, and we'll field it pretty generally. And Krishna asks, what does it mean to be routable or not routable in a network? So I'll jump on that real quick. Basically, and you might have a specific request on this. We can actually chat later too if you need to. But most basically, we're talking about, like a layer 3 function. So you have early in this slide deck. So we're actually let me just jump back there. So pardon the jumping here. Let's look at this network. This is network 1. Let me get my laser pointer back. Network 1 and network 2. There is no routing going on within network 1. And there's no routing going on within network 2, unless we have engaged this gateway router on layer 3. So I'm glad you bring this up, because I did want to emphasize one thing. We just talked about the physical layer, so that's no routing going on there. The data link layer, you're talking about frames and switches and MAC addresses, no routing. Frames, switches, MAC addresses. On layer 3, we're talking about packets, IP addresses, and routers. Again, layer 2, frames, MAC addresses, switches. Layer 3, packets, IP addresses, and routers. So for something to be routable, that means it's able to go between networks utilizing layer 3. So that's the quick answer. Definitely throw another one in the chat. We can get back to you later if you have a follow-up question on that. So pardon as I jump back through this real quick, everybody. Okay, almost there. Hooray. Okay, we've made it. All right, before though, we jump into a little demo, I did want to actually ask you where you're all at on this. Yeah, have you ever configured one of these things? Have you ever configured a managed switch? Do you have no idea what I'm talking about? If so, this is the webinar for you. Real quick, just by way of definition, let's talk about what these things are, and then we're going to go find them in the Hermes 2000 management interface. The Hermes 2000, of course, is a NovaTech product. I'm familiar with it, so we're going to show you there in the web UI. There's, of course, other companies that have slightly different web UIs or terminals or whatever. But it'll be web UI in the Hermes today. So first, a VLAN, just to tell you what that stands for. That's virtual local area network. So you are now using like logic within the switch and in the network processing unit to turn one switch into multiple isolated networks, even within the same switch. And there's reasons you would do this. Obvious one is you don't want to have to necessarily buy a new switch for every network. So there's an economy option. There's also security things as well. You might be grouping by function, application, and then you also can even reduce congestion on your network. So one that I've heard in real life utility world is we have one switch, but we have cameras. And so they want to have the cameras and even their other stuff on the same switch because that's their constraint. But they don't want anything that would be on their, like a communication to their relays or something, to be affected by the cameras. So they're using VLANs for that. And that also kind of leads us into the next comment. There's also things you can do with quality of service or priority. Even using VLANs and managed switching, you also can say, I'm only going to give you this much resource from my switch, or this much speed from my switch for your, say, camera application from what we just talked about. That might not be the best example. You might have a better one, but that would mean that, say, you have some protection functions even in this switch, they are not going to be unprioritized relative to the relatively unimportant camera stuff. Okay, also you just can do bandwidth management, congestion management. There's a security aspect to this. So if you need to do port security, you can just straight up turn off the port. You also can use VLAN tags for certain things as well. We'll get to a little bit more about what those are, but not too much. And then we'll also touch briefly, this is actually RSTP ties in on those architectures that Tom was talking about. RSTP, like if you didn't have something like RSTP or one of these redundancy protocols, RSTP stands for Spanning Tree Protocol. It's Rapid Spanning Tree Protocol. But if you didn't have one of those and you connected switches in a ring, the switches have protocols that are who has this. And then if you were to send a packet on a switch that's effectively plugged into itself, although it's through several switches, you would have this race condition where this, you say it's in a ring, it goes around and around and around and around if there's no control system for your redundancy. That's where RSTP and its cousins come in. So I won't go too much into which one's better, why you would use them. There's also IEC 61850 specific ones called PRP and HSR that are quite good. So that's a decision you have to make of what you're going to use. We do have one question. If you configure VLANs, is the question, are the ports completely isolated? And I'm click on it, make sure I got the whole thing. And he's saying, well, how well does this keep a network separate? If you configure it right, they are entirely separate. It's like I took a saw and cut the switch in half. So assuming the switch is implemented properly, once you put two different VLANs and you've given them no way to talk to each other in your configuration, it is as if you have two different switches with nothing plugged into either one. You do have the ability to create what's called a trunk port or a tagged port, where you can say, I have switch side 1 and switch side 2, but over here in port 1, that's going to be my uplink port, and it's going to send all the data upstream. So you can combine them, but it doesn't mean they'll be able to talk. It just means that let's say there's a master switch above this, we'll be able to see all of it. But in its simplest form, and I'll show you this, if I don't check boxes to allow them to talk, they won't be able to talk. So turn off my laser pointer here, and this is actually the last slide for this section. So I'm going to jump over to my share of the Hermes 2000 management interface. Thanks everyone for hanging in there. This is going to be a little bit of a demo now. So let's go to share something else in the webinar. Let's go to the management interface over here. Tom, please confirm. If you
I'm
can
looking
see
at
it.
a Hermes sign-in.
All right. Okay,
And
well.
I do have one more question on mirroring ports.
Oh, cool. All right, the other question is, how do you implement a mirrored port to monitor all traffic? I'll try to touch on that. I don't have, if it doesn't show up relatively quickly, I'll get back to you on it, but effectively you would, it would be like having that tagged or trunk port, but you would set it up a little bit different. Let's see if it appears directly here. Otherwise, I'll reply to you on the side. Thank you for the question. All right, so let's log into this sucker. This is a Hermes 2000. All right, no password manager. We don't need you right now. All right, so we are here to first configure some VLANs, or at least show you how to do that. So this is a status page that you'll jump up on here. If ever you have a question anywhere in the Hermes 2000, let's say I'm really curious about the network general page, I can jump down here and hit help. And this might not show up for you. I hope it does. Help button. It does not appear it did. It'll pop up a help menu keyed to that page. All right, and since I shared just by that window, you won't be able to see it unless I get it. Try to get it right here. Show you what that looks like. There you go. It'll pop up this keyed to what you asked about. So I clicked on general network statistics. So close that and let's go. All right, but let's go to the VLAN. It's under configuration. This is where you'll set up a VLAN. All right. So configuration, now we have all these options. We're going to jump to VLANs. Remember, if you don't know what you're doing, you're just going to click help and it'll give you a little bit of an explanation of how it works. Let's set up a new VLAN. You can see right now the owner of this switch has 1, 2, and 30. A note about VLAN 1, it's very short, and remember it, do not delete it. That's going to be your entire instruction on VLAN 1. If you really know what you're doing, yes, you can delete VLAN 1, but that's typically your configuration VLAN, your how you get into the switch. Any good managed switch will show up with all ports on VLAN 1, just so it works like an unmanaged switch out of the box and you can talk to it. Typically, you'll set up your other VLANs as VLANs 10, 20, and 30, and you'll leave VLAN 1 alone. You can disable it eventually if you want to. But let's set up a VLAN. We're going to do VLAN 40. We're not going to enable him because this switch is actually in service on someone's desk. All right, and see down here, you can now assign ports to a VLAN. All right, so let's say I want VLAN 40 to have this middle batch of ports here. I'm going to click untagged on them. An untagged port is what most devices expect, unless you're getting into specialized equipment, which does happen on the utility grid, right? 61850 has a lot of tags in it. Precise PTP, precise timing protocol, has a lot of tags involved with it. But say your computer plugs in to this Ethernet switch, it's looking for an untagged port unless you have some special settings on. So we'll just usually click untagged. If we were going to split this switch in half, I would create, VLANs 10 and 20, and I'd give the first half of the ports to VLAN 10 and the second half of the ports to VLAN 20, and not cross any boxes between both of them. And then you would have two separate switches. That's like the super simple demo of a VLAN if you want to prove this out to yourself. All right, so let's apply this. Give it a second. ID already in use. Fine. Give it VLAN 50. All right, nice. Cool, so it told me, I must have double clicked it, that's why it was mad at me. So I clicked 2 times and it told me I was being a little bit too spastic for it. All right, I created VLAN 50, you can see here VLAN 50. Quick note on QoS or priority, we're gonna click under configuration networking. I now can go, hold on, port, excuse me. You can go port by port. This switch has 28 ports. And you can see, first of all, this user of the owner of the switch only has port 7 plugged in right now. You also can see what type of SFP is plugged in to each SFP port. So let's go look at ETH28 and say we were going to change ETH28. I do see we have another question in here, and I'll get to that in just a second. For QoS, though, I can limit speed right here. That's a quality of service function, or just a simple speed limit. For port security and port disabling, I literally can just turn the port off and make it not work. So if you want to have specific ports do specific things, you have control of that here. I can set the priority of the port. So based on the traffic coming into the port or a couple of other things, there's many many variables here. So I'm just showing you the general. You can also set what mode priority is decided on by port. So you can have a priority based on the VLAN tag of the traffic coming in, or you can actually do it by IP address coming in or by port coming in. We're getting into the weeds if we do that, so let's not do that here. But real quick too, I want to show you some layer 2 redundancy. All right, you have 4 options on this switch. We had talked about RSTP, so we're going to click RSTP. First of all, you'd have to apply it. I'm not going to do that because this switch is in service and I don't want to change the way his switch works. But then you would have a couple of settings under RSTP, and you could hit this help button and read about it right on the switch. It'll give you how to do it. But RSTP will have a couple of values. There's something called a distance. So like you would have, it's not like physical distance, but it's an idea of how far in your spanning tree, how many, you might call it hops, you have to go to get somewhere. And so you can configure your spanning tree with pre-configured distances. And there's a whole thing of how quickly the network can recover. Spanning tree, though, it takes several seconds. Whereas your 61850 based protocols, HSR, PRP can go much, much faster, which is desirable. So not to launch too far into HSR and PRP, that we've covered that a little bit on another power hour that you can find on the community, and also it'll take quite a bit of discussion, too much for a basic power hour. All right, quick question answer here. The question is, in 61850 Goose applications, how important is VLAN IDs? They'll be used for sure. You have to make sure the traffic does exactly what you want. So in 61850, there's like station bus and process bus, and one of those is carrying a ton of metering data, and you wouldn't necessarily want Goose to be sharing anything with, because Goose carries your protection in it. You wouldn't want your protection to live in that fire hose of metering data. You would have to separate those. And there are ways to do it. I'm not going to show this right now, but yes, VLAN IDs are important. VLAN tags are important. Let me share back to the main slideshow. So one moment for that. Share something else. Applications and slides. Solid. Okay, so that was a quick run through of some layer 2 management concepts. We'll have to, Ivan, we'll have to get back to you on firewalling on this switch. So stand by for that, but it won't be on this broadcast. We gotta finish up and get to the last topic and any further questions. There was also a question of if this will be recorded. Absolutely, it'll be recorded. So be looking for that in the next few days. It could be as late as Monday though. So, all right. This is not part of the basic networking presentation. This is just something that we thought you'd be interested in since you're on a NovaTech webinar, and it is, I guess, a basic networking product. This is the Hermes 1000. No, Hermes 1000 is not a layer 1 switch. That would be a hub. It still operates on layer 2, but it's an unmanaged IEC 61850 gigabit switch. Now that's a lot of words to say. You just plug this thing, it's plug and play, and it works. But also you can beat the absolute tar out of it because it's a 61850-3 certified switch. So that is a standard for substation hardening that has some high bars to clear. So these two products shown here, there's a rack mount version, the 1000 and the 1050 on the right, as you order them. They both pass these tests, and that is to some level no packet loss under serious duress based on the 61850-3 standard, which you probably can read about in your favorite chatbot AI or such thing, or ask questions about if you're really curious here. So unmanaged rack mount network switch. Let's show you what we got here. First of all, we got ports, 24 ports. These ports are modular. I do not recommend hot swapping them, though I need to check exactly how durable they are for that. I would probably power down generally if you can help it, if you got to swap these ports out. But there is a fiber plug coming soon, so you'll be able to take out a block of 8. You also don't have to order it full. So that's my understanding is you can order piece by piece on this, but I'll have to check. Had a question come in I will get to just a second. We have a high voltage and low voltage power supply that you can mix and match, or two of the same. Again, I'm not sure about hot swapping. Typically, I just avoid that because you can't always, but that's a recommendation. But these are modular. So this is supposed to be your best friend, versatile, and inexpensive for what it is. So Hermes 1000 question, can it handle PTP? Yes, you can run PTP through it. There is another level of that called PTP transparency, which the 2000 supports. The 2000 has the additional ability to network offset, and we're talking very small fractions of a second. So if you're in a LAN and this was in there, it would not ruin your PTP. But if you're starting to go through a lot of routing, you want to have those offsets, and you'd probably move to the 2000. So that's my understanding of, yes, it can handle it, but the PTP transparent edge clock functionality exists in the 2000. The 1000 that you're looking at here can work, but doesn't have the managed smarts in that area. So it would work though. And here's its little cousin. This is the 1050. This is the 1050. I see one more question here we'll jump to. The 1050 is um, the smaller DIN rail or panel version of it. Just as a general idea of what these, it still has all the hardening. They both have the 10-year warranty that we would put on any of our products. Just a note though, you are looking at a pretty inexpensive all metal switch for what this is able to do. So the idea is this could go just about anywhere. There is a fiber version on the way of both of these. Yes, low voltage power supply, Ivan. Gustavo, can we create VLANs in a Hermes 1000? No, it is an unmanaged switch. You would be looking at the 2000 for that. All right. So high voltage and low voltage supply options. The one shown here appears to be a high voltage kind of wide range AC or DC. There is a low voltage option for this. And let's show you what you can order today. 4-week lead time. You're going to see on the next slide that I didn't update it, but 1 second here. they're both like the 4-week lead time. You have high voltage and low voltage and different options within that. So right now it looks like you're ordering 24T or 8T. And I'll have to check about mixing and matching ports once there are fiber options on these. So that's kind of what you're looking at. I won't read them all to you. All right, lead time is 4 weeks for both. That slide used to say pending and now it shouldn't anymore, but 4 weeks for both. Okay, all right. To kind of land the plane here, just wanted to say thanks to everybody again for joining. Want to point you to the community. If you want to review this webinar about and review Tom's excellent presentation of the physical layer, etc., you can see older power hours at novatechautomation.com/community. There are other resources too, data sheets, tech notes, latest links to latest software and such. So definitely check that out. The customer support site, these are 2 sites. You kind of log into them the same way. You go to these sites. This is support.novatechautomation.com. It'll say log in, and if you've never logged in before, it'll send us a request to log in, and we can get you guys set up on this. This is a very cool utility because you can get all your different types of software, hardware, etc. But also for your firmwares and everything, but you also can share files with your application engineers. So if you need to put gigabytes of files for the site we're working on together, of pictures or whatever, you could do it here. They do clear after about 6 months. So you also can view and service like your Orion's registered to your company here as well. All right, and last but certainly not least, don't forget that you can book time with me or Tom or any of our application engineers directly via booking.novatechautomation.com. That's booking.novatechautomation.com. And it's live linked to our calendars. So this will throw a 30-minute meeting on our calendars. It doesn't have to stay 30 minutes necessarily, but you can ask anything. If you have an application, how's this work? How can I use this? Just feel free to do that as well. And lastly, just wanted to say thank you very much for your time. Last call for questions. Okay, the good question. Is there going to be an 8-port managed switch like a 2050? Stay tuned on that, Jason. It probably. Okay, so I can't comment on that right now, but that's something we're discussing. So good question. Any more questions? If not, we could call this done, but I'll hang on for a little bit and try to answer a couple more. All right. All right. Yeah, got some questions rolling in. Where are we based out of? Tom and I are based out of Lenexa, Kansas. That's a west side of the Kansas City Metro. We also have team members in California from the app engineer team and Texas. And we're actually working on hiring another one. So if you've got any Anybody in mind, you could send them our way too. We're working on another application engineer right now, but that's where we're based out of. As for SDNs, that's a good question. We definitely have some time here, so feel free to throw more questions. For SDNs, we are not an SDN proper. So a software-defined network, it sort of breaks the 7 layers. You're recreating a network in your own image. So none of the products we carry right now support SDN. They are out there. One thing about SDN, why you may or may not consider it. So SDN, you basically have to go all in to get the functions to work for your software-defined network controller to have control. So if you don't want to go all in, you might not want to like if you want to build bit by bit, that would be a reason not to go SDN. But there are definitely some benefits, but that's a different angle. These are managed Ethernet switches that we were talking about, and unmanaged here right at the end. But SDN is another network solution that you can do. Another question, are the switches transparent clocks when you use 1588? We did touch on this a minute ago. We, on the 2000, are transparent clocks, or they call it like transparent edge clocks, the 1588 PTP. So proper implementation of that does exist on the Hermes 2000, so that's like a managed switch feature. The 1000 is not. It's not doing tags like that. I believe even PTP throws VLAN tags if you let it. It has a tagging that you're looking for. The switch would then it would recognize its offset to correct the timing as it passes it through. Like, so the network delay it's able to control. Hermes 2000 family, yes. Hermes 1000 family, not as much. All right. Any other questions? You can see our emails here too. Feel free to start typing emails to us anytime you want. It's what we're here for. All right, another question. VLANs, yeah, tagged VLANs. There are many applications for VLAN tags. It's really locking down and controlling your network. I won't dive super deep into it, partially because I'm not the expert on VLAN tagging necessarily, and partially because there's a lot to say. But when you start doing things like, I believe PTP is actually one simple example, is there would be some tagging involved with that you'd have to recognize. Then there would be, yeah, for station and process bus, you would have tags for priorities and things like that. But, in your simplest, connection, so like you're going to connect to a relay or something, you might not have much for VLAN tags if you're just going to do simple relay protocols. Okay. So I can follow up further. Definitely hit me up later, Krishna, if you want to talk more about that. I can speak more fully about it. All right, Philip asks voltage for the switch range or the switch power supply ranges. So the Hermes 1000 first has modular power supplies, so you can use one or two or both or swap them around. There is a low voltage range, which usually those are under 48. And I'd have to check exactly what that one's going to be, but say 48 and below. It could be 12 to 24. I'm not sure where the cutoff is without double checking. I think it's actually up here. Let's go to the ranges. Power supply ranges. What do we got? On this screen, I can see 18 to 60 volts is low volts, and then 80 to 300 DC or 85 to 264 AC is high voltage. So that's on the Hermes 1000. It's a little bit different on the 2000. And also the 2000 is a fixed frame and it's even more rugged than these basically. So they both pass the standard, but the layer 2 managed switch passes it harder, if that makes sense. All right. I think we will sign it off and say thank you very much for everyone joining. It's been a lot of fun to present this. Appreciate you all, and definitely feel free to reach out if you want to talk further. Thank you, everybody.